In this chapter, we have been discussing about units and measurements, and we have seen some methods of measurements and also the terms related to the measurements that we obtain, that are accuracy, precision, and also we have understood that while we are measuring, errors might occur due to various reasons, and we have classified the errors depending on the reason behind the error. While we discussed about errors, we have also seen a term called the least count error, which is associated with the least count of an instrument. So we have understood that there might occur errors while we are measuring. Now here we are going to see another classification of errors, which are absolute error, relative error, and percentage error. Suppose we are taking a particular measurement, and the measurements that we obtain for the same quantity are A1, A2, A3, etc. AN. So n measurements we have obtained related to the same measurement. While taking each time we have obtained each measurement, and n measurements we have taken. So in such a case, how can we say which among these values is the exact or the true value of our measurement? Can we say A1 is the value, or A3 or any other measurement that we have taken is the true value? We cannot pick one among these values. To get the best possible value of our measurement, what we do is we take the arithmetic mean of all these values. And the arithmetic mean is represented as A mean, that is the arithmetic mean of the measurement is taken as A mean, and it is given by addition of all the values divided by number of values. So we are having n measurements which are A1, A2, A3, etc. AN, and we are adding all the measurements and dividing it by the number of measurements gives the arithmetic mean of our measurement. And it can also be written as A mean is equal to summation over I equal to 1 to n AI divided by n. Now coming to absolute error. What is absolute error? Absolute error is the magnitude of difference between individual errors and the true value of the quantity. So what absolute error gives is how much each values that we have obtained varies from the true value, which is taken as the arithmetic mean of our values. So it is simply the variation of the values from the true value. And the true value that we have taken is the arithmetic mean. So for that, what we do is we find the difference of each values from the true value, which is the A mean. So to get the absolute error in the first measurement, which is A1, we represent it as A1 minus A mean. Thus the absolute error in the first measurement is obtained. The absolute error in the second measurement can be written as delta A2 equal to A2 minus A mean. So on. So this is how we get the absolute error in each measurements. And we can see that these values can either be negative or be positive. But absolute error gives the magnitude only. That is, we get only positive values in absolute error. Therefore, precisely we can write the absolute error as magnitude of difference between each value from the true value. Likewise, we will have n absolute errors, and as a final value for the absolute error, we take the mean of all these absolute errors. That is, delta A mean can be written as sum of all the absolute errors divided by total number of absolute errors n, which can be written as summation over I equal to 1 to n delta AI by n. So this is the mean absolute error that we obtain, and it is written as delta A mean equal to summation over I equal to 1 to n delta AI by n. While finding absolute error, we should keep in mind an important point that Absolute error is always a positive value. So even if we take the difference between each measurements and the mean value, we might get a negative value, but we have to neglect that negative and we have to consider only the magnitude. So we are in a process of measuring a quantity and we obtain first various measurements. Each time we measure the quantity, we get each values, and based on that we found the true value for our measurement as the arithmetic mean of all the values, which is written as A mean. So the true value is taken as A mean, and also we found that the error in each measurement can be found, which is called the absolute error, and at the end of that we got a final error in our measurement by taking the mean of all the absolute errors, and it is represented as delta A mean. So this is the final true value for our measurement, and this is the final error that we found in our measurement, from which we can say that any random measurement that we take for this quantity will have a value as A mean plus or minus delta A mean. That is the true value plus or minus its error. So any measurement of this physical quantity will have a value that lies between A mean minus delta A mean and A mean plus delta A mean. So this is all about absolute error. Now coming to relative error. Once we have the arithmetic mean value of our measurements and the mean error of our measurements, then we can easily find the relative error. Relative absolute error is the ratio of mean absolute error delta A mean to the mean value A mean. So relative error is written as delta A mean divided by A mean. Once we have the mean value for our measurements and the mean absolute error, we can find the relative error simply by using this equation. Now coming to percentage error, the relative error expressed as percentage is the percentage error. That is delta A, the percentage error, can be expressed as delta A mean by A mean into 100, which is the percentage representation of our relative error. So these are the important concepts of absolute error, relative error and percentage error. So the whole process of doing a problem lies in finding the mean value of the measurements, then finding each error, and then taking the mean and finding the mean absolute error. Once we get the mean value of all the measurements and we have the mean absolute error, we can easily find the relative error and as well as the percentage error.